Hi there, this is Mark. I was going to talk to you now about our patented flywheel system. If you were to take the hood off of any treadmill on the market, any one of them, with the exception of ours, they are all exactly the same under the hood. There's a fundamental problem with a treadmill, and that is, unlike any of your other pieces of equipment in your gym, you take a 250-pound guy, a 200-pound guy, and you have him jogging on this thing, and he's pounding away on this belt as he's walking along. And he's pounding away. The motor's getting all this load, it's getting all this shock and all this load into it. The unit wants to slow down, it wants to hesitate with each step, it has to overcome it. The motor's seeing this load, this bang, and then it's seeing you push off. And then bang, and you're pushing off. It's going fast, it's going slow. Ultimately, if you want to know why treadmills don't hold up, it's because of the body weight pounding on it from the user. And what we decided is we needed a way to solve that problem. Everybody else has done it the same way. The solution in the past, and that's what I'll come down and show you right now, what their solution to that pounding and the beating on the treadmill is and how most companies try to approach it. See, what everybody else does is you've got this little steel wheel here, and so here's your motor, and here's this little steel wheel mounted right onto the motor, and there's one belt right here running between the motor and the front roller. And it doesn't matter whether you have a little cheap treadmill like this or a fancy commercial treadmill. If you took the hood off of anybody but ours, that's what they've got. So their solution to overcoming this pounding is this small steel weight that's mounted directly to the motor. I'll show you what our patented difference is. Okay, and you can see what we did. This is what's different. We have a steel flywheel on ours, but instead of being a small one, because if you're mounting it directly on the motor shaft can only have so much weight. That's called overhung load, and the manufacturer will spec how much weight you can have hanging over or overhung on the motor. The more weight you have hanging out here on the ends, the shorter the bearing life, because you have this offset load that's shaking and vibrating over on the side. So everybody will keep them much, much smaller than what we do. Ours are effectively up to 50 pounds. And so you've got this massive steel weight back here. And so with this big steel weight, and two, if you notice, this is what I was saying was different than anybody else, we have a second belt. So you've got the one belt running from the motor to the front roller like everybody else, but we now have a belt running from the motor to the flywheel system, and what we call our Force Multiplier. It's a multiplier because it's running faster than the motor. And so we have a very heavy weight spinning at a very high rate of speed, and effectively, mathematically, we figured out how much weight we needed to overcome that when you had a 300-pound person jogging on this thing, we generated more force than they were generating. So the big advantage is not only do we use huge motors, and our 4-horsepower continuous duty motors are some of the largest in the industry. And there's actually a motor plate rating on these things where this motor can handle continuous power more than your building will provide without burning up. So we have this big heavy motor, but we ask it to work very, very little compared to anybody else. So by having this big motor and then having this flywheel that's spinning at the high rate of speed, remember that pounding, even up to a 300-pound guy, it's not going to be hesitating at all. All of your other companies, if you look at it, they're going to make constant claims about speed sensors, and they measure how many times a second to try and keep the belt at the proper speed. And what you have to realize with a sensor is, a sensor will only make a change when it sees a need to. Meaning that when it sees the belt slow down, it's going to speed it back up. You feel it. You feel these small variations and fluctuations, and we would challenge you to run on ours for just 30 days straight. Just it. Get to where this is the only thing you know how it feels and how it runs, and then shift to anybody else's treadmill, anybody else's, and you're going to be shocked at how smooth this thing is to run on. It has a smooth, damp, dead feel to it that as you're running on it, it's not bouncy and springy, it's not solid like a rock, it absorbs the impact, it's smooth to run on, and it just transfers it right. That's the flywheel. The flywheel has two functions. One is to make the machine last quite a bit longer, much more durable. The other is make it much, much smoother to run on and give it a really great solid feel. So not only do our heavy steel frames give this a nice feel to run on no matter how big you are, and remember, we're a 700-pound user range. That means you can take somebody, and we have a gentleman that's James Young, I think is his name, and it's 685 pounds, 6'8". And he has one of these in his homes, and he keeps using it all the time, and he's been losing weight, and he's down now, I think he's now down to about 550 pounds, which is a lot of weight loss for him, but he's still on his way down. That's the user range. The thing has been timed, the thing has been used at a whole lot heavier weight than that. And so we can handle a tremendous amount of weight. But that means that when you're using it in your normal range, this thing is barely working. It's like having a massive semi to haul a very light load. And that's why they'll hold up so long, and why we can offer such long warranties, and why we can say, it's not an if. 10 years from now, these things are still running. And so whether we redo them cosmetically, or we have to do some small mechanical maintenance things, but the actual fundamental machine is meant to last a lifetime, even in a commercial setting.